Hello, from Dr. Satish Singhal, PhD. I'm going to talk about designing software based on invariants and or business rules. This will be a C++ version. There will be other versions like VB.NET. This is C# version. There will be other versions like C++ and VB.NET. Once again, I'm Dr. Satish Singhal, PhD, Professor of Computer Information Technology at Rose State College, Oklahoma, Midwest City, near Oklahoma City. Okay, so basically, question is, what is an invariant? The dictionary meanings of invariant are as follows. You can see them at dictionary.com. Something that is unvarying, invariable, or a constant. But in software design, invariants are conditions that do followings as needed. Invariants maintain certain state of the software object, and they obey certain requirements inside a method, code, block of code, or inside a software component, or inside a class object. And if this is too abstract, this will become clear soon. Are business rules invariant? We can think of foundational rules of business akin to invariants. And good software design enforces business rules and invariants. And the term invariant is used by computer scientists who are typically not worried about business rules, but system analysts don't like the term invariant, they like the term business rules. And in many situations, they turn out to be the same thing. Okay? And we are only going to call them same thing in those situations where they are the same thing actually. Okay, we want to talk more about invariants. You have invariants, you have used invariants without realizing that you might be using them. For example, in a pretest loop, the invariant is that pretest condition must be true at the loop entry point for its next iteration to take place. So if you have a loop, pretest loop, where loop condition is tested at the entry point, well, that condition, the invariant there is that that condition should be true for loop to execute. And same thing happens in the post-test loop. The invariant is the post-test condition that must evaluate to true for the next iteration to take place. So these are two examples of invariants that you have used in writing pre-test and post-test loop without really realizing that you were using the invariants. Okay, what are the advantages of invariants and business rules? The biggest advantage of designing software based on invariants is that such software has fewer bugs and it's easier to maintain. Okay, so that's the advantage of designing to enforce the invariants. More formal definition of invariants or business rules. A software written as a class obeys invariant or business rule when that invariant is true. Number one, at the entry point of each class method or constructor. So when method or constructor is entered, at that point invariant will be true. And at the exit point of each method or constructor. In between it may not be true, but at the entry and exit it will be maintained and it will be true. So meaning of that is that even if an invariant or business rule is violated inside the body of a method or constructor, when software is designed to obey invariant, it will be re-established by the time of exit from the said method or constructor. Okay. Alright, we're going to design a class based on invariant and business rules. Imagine that we are designing a class called student, which is used in storing and processing records of a student. That could be any college or university. And we show in the next slide the UML diagram of such a class. And I'm not saying that would be the ultimate UML diagram, but partial, so to speak, partial UML diagram. This is the partial UML diagram of student class. It has following fields, all private, minus means private. Last name is string type, first name is string type, GPA as double type, age as integer type. And then we have, here's the constructor, string, these string L name and F name are passed as last name and first name. L name is initialized this variable, F name will initialize that variable. GP is the double type, will initialize the GPA, and age is the integer or age type that will initialize that. And then we have three mutators, set GPA, set last name, and set age, and a print method. Obviously you can add more, but to prove my point about, to illustrate use of invariant in design, this should be enough. And by the way, I use the term mutators. Set methods are also called mutators because they mutate the existing state of an object. And when I talk about them, I'll say a little bit more about them at that time. Okay, so in this case, we will just choose one invariant to apply to the development of student class. We have seen in UML diagram, the object of class student has a field called GPA. That would store student's GPA. Well, the software will have bug in it if somehow the value of GPA stored did not fall in the bounds 0.0 and 4.0. Because typically GPA cannot be negative and it cannot be more than 4.0. So if somehow GPA stored became negative or became more than 4, that's a software bug. All right. So all student class methods and constructors that mutate, means that change the state of student object, must obey the following invariant, otherwise we'll have a bug in our software, and this invariant we show in the next slide. So what is the GPA related invariant? And once again, this is like one of them. We can establish more, although in this video I'm not going to do that. I'm just showing an example of one of them, but to make your software or class more robust, you can have more of them actually. The GPA related invariant for a student class is that at entry and exit points of all methods and constructors, the GPA must be in the range 0.0 and 4.0. And when we say methods, we can actually specify this a little bit better. All the methods that mutate the object, that change the state of the object. For example, print method rarely changes the state of the object, so we don't have to worry about thinking that print method should have GPA in this range. If a method is not mutating the object, well, you don't have to worry about it. So methods that mutate the object, like set methods, cause the mutation. Those are the only case you have to worry about actually. If that is not obeyed, then software will have bug in it. If GPA is not maintained in range of 0 to 4.0, software will have bugs because it will violate college rules, GPA rules, if the stored value became negative or exceeded 4.0. Okay. The class field values related to invariant can only be violated for methods that cause mutation of field or by constructors that construct the object for the first time. So we just repeated what we said earlier. Okay, so thus the software we write for a student class must maintain the following invariant or business rules. So we are restating that one more time. At the entry point of any method or of class or constructor for the student class, the value of GPA field is in the range of 0 and 4.0. And at the exit point of any method of class or student class in this case, or constructor, so entry point, it should be 0 and 4.0 range, and exit point, it should be between 0 and 4.0 range. Okay, now we're going to code student class while maintaining the invariant business rule regarding GPA. And we're going to show actual coding in a web-based environment called Mono because I'm making this video on Mac. Mac does not have C# compiler, but there's an online compiler called Mono that can be used to run small C# program on the internet. So I'm gonna show the coding of the student class where the GPA invariant has been maintained. Okay. All right, so let's go to our code, and here it is. So it could be, I suppose I can make it a little bit bigger for you. Okay. Although, so the way this is set up as compileonline.com, you can write here the code, and when you click on compile and execute, it'll basically run at that time. Let me make the full screen here so that you can see a little bit better. So typically I have shown before that student class or any class and the main method should be written in separate files, but you could write them in one file if you wanted to. Okay, that's not a problem. Okay, and we were having this problem that somehow Safari minimized itself, and that's a recent problem. We haven't had that problem before. Okay, so let us see how we wrote the constructor so that invariant for GPA is maintained. So here's the fields: private string last name, private string first name, private double GPA, and private int age. So coding the constructor to obey the invariant. So constructor will take 4 arguments, one each to initialize each of the data members. We're not enforcing an invariant in the last name, first name, and age, but we are only enforcing the invariant through our extra coding on the GPA. So some value of GPA will be passed when the constructor is called, like here. Okay. So for other 3 where we are not enforcing an invariant, we just make a, and once again, as I said, we are having trouble with Safari just today, auto minimizing. We code them as is. Last name equal to L name, first name equal to F name, age equal to AG. But now for GPA we enforce the invariant. So we say if GPA is greater than 0 or equal to 0.0, that means it includes the 0.0, and GPA is equal to 4.0 or less than that, then my assignment of GPA class member to this GP that was passed to the constructor is correct. Otherwise, I have violated the invariant. If I make this assignment, if this composite condition is not true, I would violate the invariant. So in that case, if this composite condition is false and invariant violation will take place, then I tell the user that illegal value of GPA was entered, and I print that value, and I set the GPA to 0.0, which is not violating the invariant. And of course I inform the user that this has been done. Okay, you may ask that, okay, what will happen if GPA was not 0.0 and user had some other value? Well, in that case, there are set methods right here that can be used to set it later. All right. Okay, so how do we enforce invariant in the set GPA method, which is the other one that causes the mutation of GPA? Well, there also this first condition is coded as this, that if invariant is obeyed, that means this condition will be true, then I set GPA to GP. But otherwise, I have a change. But the change is a little different than the constructor, because object will be constructed by using the constructor. So if this invariant is not obeyed by the value GP that we are trying to have a new GPA as, Well, of course, we still inform that value of GPA is illegal, but this time we don't want to make any change. There's no point setting it back to 0.0 because the previous value may be a good value. Okay, so only difference between constructor and mutator set GPA is that here in constructor we didn't have a good value and we needed an initial value, we set to 0.0, and here we don't make any change because the previous value will be a good value. Okay, all right, so to show this how this all works, I have a print method here which prints the student's name, age, and GPA. And then in the main method, we are making two constructor calls. One that has a good GPA within the invariant, other does not. And then each time we are making a call to the print method. Okay, so let's execute that. Okay, so when the GPA was correct, print method acted normal and we printed everything. So this was John Doe 3.4 and age was 23 years. But here we're passing a illegal value of GPA. Sorry guys, we're having this trouble with Safari today. So here we're passing a 5.2, which is an illegal value. So for that, first message we get is from the constructor that illegal value of GPA has been set to 0.0, and then the print method gives you a value of 0 that was set by the constructor over here. Okay. Well, same thing we do with the set method. So GPA for object std2 was set to 0 by the constructor here because the illegal value was passed. Well, I can use the set method to set it to a better value. Set, and I hope my syntax is correct, GPA, and let's say I have a value of 3.2, which is a correct value. So this will be fine, and if I repeat the print command, it will print the GPA that we did set. So the third output after this, you will see. Okay, so I think, okay. Okay, this should have worked. I don't know why it didn't. Let me see, std2 dot unexpected symbol. Oh, I forgot the semicolon. Sorry about it. Yeah, that's the problem. Yeah, I forgot the semicolon here. That's why. Okay, it'll work now. Yeah, there you go. So this extra output we have now is student name John Doe, age 23 years, GPA 3.2. So that's correct. But if I try to set GPA to some other value, which is, let's say I should take both line and copy and paste them. So this time change it to something. Both my Macs are having this problem today. Safari minimizing by itself. So really don't know what's going on. So let's say once again I enter GPA of minus 4.3. Okay, and of course don't forget the semicolon. Oops, there you go. So this should say GPA is illegal, and earlier the GPA was 3.2, so it should still print that 3.2 GPA. So let's focus on the last output between the dotted lines. Okay, and here it is. So set method is now enforcing the invariant by saying that illegal value of GPA 4.3 was attempt was made to set a illegal value of GPA 4.3. And no change is made to previous GPA value, and that's proven by printing it again. Notice here we have GPA 3.2, and that was the previous value also. Okay, so hopefully we have illustrated to you that how constructor enforces the GPA invariant and how set method enforces the GPA invariant in the class student. Okay, and thank you for watching. I'm going to have another version of this for Visual Basic and C++. Once again, this is Dr. Singhal. Goodbye.